Hello, good morning. Welcome, everybody. I see we have about 20 participants who have just joined us, and we're expecting more to join. But I think in the interest of time, we will get started. It's 11:30. So I'd just like to welcome everybody to our first Industry Talks webinar of 2023. For those of you who are joining us for the first time, Industry Talks is a bi-monthly webinar series where we invite professionals working in industry to speak on a topic related to software engineering and AI. My name is Lori Akiyama. I'm the program coordinator for Create SE for AI at Concordia University here in Montreal, and I'll be moderating the webinar. Today, I am beyond thrilled to welcome Dr. Gabor Melli as our guest speaker. Gabor is VP Engineering AI ML at Medable Inc, which is a software company based in Palo Alto, California, that has developed a software as a service platform for DCT, decentralized clinical trials, that is currently transforming the digital medicine space. Gabor's impressive professional experience includes leading teams and driving change within organizations, both large and small, such as Sony PlayStation, Microsoft, AT&T, DataSage, and Meals.com. He has also presented his research at many applied AI research conferences, including AAAI, KDD, LREC, and ICDM. Today, Gabor will be speaking about deploying effective machine learning models in production through two use cases. This webinar is being recorded and will be available to view on our Create website at se4ai.org and also on our YouTube channel. So I'll ask that you please keep yourselves on mute until the Q&A session at the end, and then please feel free to raise your hand in the chat. So with that, I will turn things over to our man of the hour, Gabor. Gabor, please take it away.
Thank you. Thank you for that introduction, Lori. Wonderful to be working with you on this, presenting, and Emma as well. So yeah, I've been in the industry a while, and so when I was approached about some opportunity I could share, and I thought I would pick my two recent experiences at PlayStation and now at Medable to describe the process of actually making this happen, how to translate all this amazing research and progress in AI and ML into production. And the fairly different processes. The one about deploying is kind of critical because that's the real nuts and bolts, maybe closer to what you'll face in the real world, in the industry, in your own future lives. So yeah, let's proceed. Well, this is, let me share my screen. Is that coming across okay? I will assume it is.
It is. It's perfect. Thanks, Gabor.
Super, super. Okay, so let's see, hopefully this is working. Sure, I mean, this is just a copy of what the talk's blurb is, so I can skip that, and maybe I'll start with something provocative to say, this is not a talk about ChatGPT and all the amazing progress and neural language models through the transformers, though I'd love to talk about that in a future session. My history academically, my PhD was in NLP, and I worked on document summarization, so I'm particularly impressed by the progress and applicability of those innovations. But today, I'll go into a couple of scenarios. One is at PlayStation. I joined there, gosh, now it's about 6 years ago. Then I left a year ago to go to Medable. And there, surprisingly, they didn't have yet a mechanism to deliver personalized messages. And it makes sense as to why not, because it's large scale. This was over 10,000 users per second, and all these constraints made it particularly difficult to deploy. So I'll tell you this story, which will become ever easier and hopefully easier. This is something you might face yourselves. So one thing to note, that's 100 million active users and 40 million subscribers. So these are long-lived relationships. And so these technologies can help to nurture these relationships to achieve this, the vision of entertainment and interactive entertainment. This is the PS4 sales, and for PS5, where the trajectory is very, very similar. It's broken the same records. It's so this will be the same track. So it's growing quickly, and in part because of this wonderful, rich experience where there's a place to buy things, a store. There's a social world where you can interact with your friends and players, video, music as well. Lots of content that's difficult to navigate, and there's lots of opportunity to really personalize the experience to what is most interesting through recommendations, possibly because of who they are. So this is a kind of a visual summarization of the user profile. So now we're talking about information, data that we have that can help make the match. At the bottom, suggesting that there's friend information. So, okay, then now I'm going to work through this scenario and help you understand maybe how we thought about it, that there's this profile of the customer that needs to be enriched and needs to be updated very frequently. And that didn't exist when I joined, so we need to create that. This is the context. The context is particularly interesting. We're global, so what country are you in changes what we recommend, what time of day, what device. Now, we have content that is, in this case, it's games, and that's just some identifiers, and we have hundreds, sometimes thousands of items of content. And what we need to do is, with all this information, to pass it through a model and rank it with decreasing relevance so that we can put the most relevant content in front of this user. And all that has to happen in under 20 milliseconds, which makes it, adds to the complexity and the challenge of delivering not just the training, but the deployment and putting this into production. Now, if we have a new user, then clearly the recommendations need to reflect that user's preferences. Or if we change the context on a new device, a different time of day, possibly a different country, then that should be reflected as well. We're getting to experience this all over. I've noticed myself as I use different devices to turn on Netflix, say that it knows that I'm somewhere else and changes recommendations. Or if the person's decided to depersonalize, turn off personalization, so we don't have the information about the user because of some privacy concerns that they should rightly have, and the ability to turn it off. And so then we still need to be able to provide at least some generic personalization that at least reflects the contextual situation. So to do that, we built a scoring platform for relevance. And I'll skim through this as this is being recorded. So this can be reviewed later if needed. All this information, I've kind of verbally said it on top. To support that platform, we had to and decided to build others, including the data processing and machine learning platform. That's possibly what you're a little more interested in about now, is how to actually deploy these solutions. What do you need systematically to do that? And in the middle, we can benefit from the synthesization, the characterization of the customer data and the item that's being ranked as a first level bit of information that can be managed independently. Plus all this more, just to kind of overwhelm you, impress you with all the different components that are required. It's non-trivial to do this work. You better have a use case that can really benefit significantly from this technology, because it's still a very big investment, which clearly PlayStation had it, and now at Medable for me. This layer is where I'll get a little more into more detail. The idea that we need to store models, we need to store features, the inputs to the model, record how to improve how to train it. And there's plenty of challenges, so I'll skim through some of these, but without this, then it puts a lot of friction and requires months to do this instead of weeks, instead of days. At PlayStation, we're on Amazon Web Services, And so with these kind of a flavor, some of the technologies we've used along the way to move all the process, the pipeline, in a fairly predictable manner. So lots of technologies, and I guess that's a bit of advice is not to necessarily get too prescriptive in figuring out the technologies themselves, because they're going to keep changing, but pick any one to really get to understand what a key value store say is. This is now moving on to this platform that focuses on the data and about the customers. Plenty of challenges here, including how cost effective it'd be. We need to have this information available within milliseconds, cached all over the world, and so that's expensive. There's some trade-offs to be made there to host this information of users, items, and the interaction between them. Can become very large and costly. And so here we're using some key value stores and S3 to put all this information in a data lake. Now that we have all the components to actually possibly add this new service, a service on top, it's relevant scoring. Let's talk about one of the challenges here, and that's how to personalize for, let's say, the less active users and on the less frequently used items, but the items that are and users that need to be particularly served well. So this is the visualization of the long tail for customers and the interactions, how often they come and frequently they use our service. And same with items. There's items move from left to right as they become less hot, but still very interesting and playable. And it's easy to service personalization on the left-hand side. Let's always give people popular products, but what about all the other content? And that is one of those challenges of skew. When the data is really skewed, it can often challenge machine learning algorithms to make a prediction about something that it's going to need to often make mistakes at, and so an algorithm may want to be conservative and always pick more popular things. And that's a highly skewed. So on the rows here are the different items that we can recommend. The entirety of a game. Nowadays, there's lots of add-ons to games, user-generated content, or whether it's a party or a community or individuals, 100 million people, that clearly is highly skewed. But all of these other challenges are also interesting. They just happen to apply to maybe fewer of the items, but algorithmically, they introduce their own challenges to address. Today, just for brevity's sake, I'll focus on only one. And that is, that the highly skewed approach means that we would apply things like collaborative filtering and neural collaborative filtering. We would address this by mostly giving it the right evaluation function. So when I challenge a team to improve on the performance, while then trained in an offline world, we had to provide the right metric that rewarded predicting content that was not just fresh, but even from the backlog. So that's my kind of flyby from the PlayStation world. You got to see all the different layers of concerns and some of the many challenges that we encountered. I'll transition now to the Medable space, where here we're trying to transform the clinical research, clinical trial space. And we're riding the wave of smart devices. So the idea of a decentralized clinical trial is the fact that you don't have to go to a physical site. You don't have to go to the clinic to do all the clinical tasks, clinical research tasks that necessary, how to fill out forms. Instead of doing it on paper, now you can do it on your device. Now we can get more signals from smart devices about, let's say, heart rate and your sleep patterns. That's the vision. the mobile phones are clearly the easiest to translate from paper into phones, and to do it all around the world. So the vision for Medable is to get these therapies and prove that they're effective to patients faster. And this requires that we capture this data digitally and do some real-time analytics, and to remove the complexities and dramatically reduce these timelines. Further, maybe beyond this, part of the motivation is diversity of the population, that we can now be global. So we have over 100 languages that we support in the product. That means that we can get the entire world to participate in a clinical trial. Is another way to achieve the goal of effective, safety for these devices and drugs. To help you transition from the video game world now into this world, which I guess is partly will come with the territory for yourselves as you apply these technologies. You'll often need to change domains and understand the domain. And here's my quick review of the domain to help you understand the opportunity. So Medable has dramatically reduced the timelines of this second chevron, the clinical research space, which translates often to clinical trials. And recently in Nature magazine, Nature Medicine, just earlier this month, I couldn't help but share this. There's a sense that AI can really help motivate and reduce these timelines. So let me read this, share what I'm seeing here. So one of the rows here is the current versus a possible envisioned AI-powered or facilitated clinical research pipeline. And we, Medable, is most often typically associated with phase 1, 2, and 3 trials. In this area, there's a sense that instead of it taking 8 to 10 years, it can be brought down to 2 to 3 years through automation. Recently, I've been changing AI to be, instead of artificial intelligence, to be automated intelligence, and ML to be automated learning. So let's find out how opportunities for how. Now, this is a paper that suggests that can be done. I have some glimpses to where that can take place for us. Clinical trials. So let's say this is one of those phase 1, 2, or 3 clinical trials. This is a typical process that would have to go through that involve very different activities. One of the amazing, and maybe I'll instead of talking about these 6 activities right here, I'm going to do it this way. I'm going to talk about the artifacts that are produced, or some of what is the output of them. First, there's the input. The device goes into the input, the therapeutic. And now a protocol document is created. There's amazing science where an over 100-page document describes the study that's about to be unfold ahead of the science being performed. So that's excellent. It will be, so that's good practice. It won't be biased by what we discover. And now once we have the protocol, we go through all this work to come up with a report of how effective and safe the therapeutic is. Excellent science. There's been, this is the gold standard for how to determine where therapeutic. You always, sometimes it just looks too good to be not healthy, but who knows, sometimes there's some safety problems along the way, some side effects that you wouldn't want. So each of these stages produces different things. Now we need a stage where we produce the app that works on your phone or on the website. And that's the one you see. There's lots of other systems that need to be created. Then you have to select these sites. These sites are the ones that have their existing relationships with possible participants that meet the criteria of the study. We have the right age category, the right ailment. There's plenty of other criteria that they want. And now we recruit and screen, screening that they meet the criteria, but also then consent to the study. There's some of them involve injection, say, or some intervention. that needs to consent and or others. So, okay, so now we have these. Then finally, what you would think of this main process of doing the study creates the data, creates the goal data that now we can use to assess the safety and efficacy. Fine, so now I caught you up to the space quick in a few minutes. What I want to layer in now are these tools, these hammers or wrenches that we have from this world of AI and ML, such as sort of simple predictions of classification, regression, rank, or anomaly detection or forecasting, where there's a strong time series component. Maybe also drive an intelligent user interface. That could be recommendations. That's on the left. Now on the bottom, the right is natural language generation, understanding with the kind of tools that are now practiced. Of course, if I could see you all, I'd ask for a show of hands on who's used these NLG tools of ChatGPT and now Bing and Bard. Plus then translation, since we have 100+ languages, maybe the machine translation technology could be used, or vision. So sometimes it's important to be able to see some kind of wound or something about the surface. So vision can be a part of what might help expedite the trial. And you have to trust me that after a little bit of homework, I can make claims about the application of each of these possible technologies to each of these different activities. And we now need to determine which ones to invest in. We can't invest in all of them. We need to focus on ones that we can sort of show progressive improvement. And I'll show another way to look at it. In part, not only is the business value need to be there, but the complexity. So these image processing takes a while. Language processing is kind of complicated. Could we start with forecasting and timeout and outliers as being our investment? And that is what we've done in my first year here. I built a team, and we've begun to investigate some simple predictions of time. So here's a simple example. One of the ways to understand an opportunity is that there's an individual, one of our customers on the top left, one of our users, who wants to predict something. They want to predict a series. The FPI on the bottom left is the first patient in. So there's a new study. They've just got the first patient in. They've signed their consent form, and now we want to increase that pool, so we reach that threshold when the study can commence, because now we need a certain level. How long will it take for that to go? So today's here, let's say for the last patient in, and that's when we reach our level. Let's say in this case, it's some simplified 7. This is a clear prediction problem that our tools, machine learning might be, definitely able to achieve this kind of prediction with some certain confidence and bounds. I started here fairly simply to show that this is how we want to start in our work, something simple to predict. And that one idea, that one service, I say it as a service, is something we can put on our cloud as a service that now our tools or applications can reference, is reflected in this row. It's rather kind of small here. It's not too important maybe for you to understand the details, because you're going to end up in a different industry altogether. But the intent was to assess the benefit and the difficulty of delivering the service. And once, say if I go forward, once I now look at a larger set of ideas that we've investigated, we do this kind of ranking of where we see the strongest benefit based on the value to the customer, the value to us, the technical complexity of doing that service, and then where we could see what stage of the life cycle of a trial would we apply this, and data. Without data, we can't work. Do we have data could actually support each of these. And so there's one service. So that would be applied in study execution. I'll share some. So for now, this is very early work, so I'm going to keep it at a high level, and mostly this is kind of gives you a taste and helps you to maybe ask some probing questions when we get to Q&A. But I'll get into some more information about this domain. That's very interesting to see how we might look at this data. So here is, I'm going to share you some real data. This is real data about some specific participant that we've anonymized. We don't know who this person is specifically, but we see that they answered some questionnaires on their app. In fact, on this day, on September 10th, participant X completed 5 tasks. Tasks being some kind of questionnaire: how are you feeling? How was your sleep? Etc. And then spent about 200 seconds completing them. So the 200 is the blue, goes if you go to the right, the blue, while the red is task completed. Okay. Now, this is the now that I helped you to understand one of these columns, one of these days, here's the rest of the days for this participant. At the far left, you can see that they have the most activities. And that makes a bit of sense, where when your very first day is often when you have the most information to collect. And then after that, it's more of a check-in. Well, notice that there's some clear gaps. It's typically that there's daily activities, but sometimes they're missed, and missed days are not good for a clinical trial investigation, because missed days means that you're missing the data. And as more and more of these gaps exist, then it becomes ever harder to make a good assessment of this safety and efficacy. Now, but actually, this is maybe not too bad for this participant, because here's a different participant, and notice their behavior on this exact same study dramatically differently. And then they miss out all these tasks here. Maybe they dropped out temporarily, and now this can be quite problematic for the study. So if we could predict this individual ahead of time, maybe they're having some difficulty with the app, who knows, and if we could warn the site earlier about this situation, then they could intervene and have a conversation with participant Y, because before they would come to the office, and the site would know that they haven't shown up to the office. Now the bar is higher, and they don't have direct conversations with these participants, especially with the hope that we will have thousands of these studies, thousands of these participants. It gets harder. We need to automate. There's one that you could imagine could be automated, have a predictive model that's attributed to this, predict if a participant has dropped out in the study. And that's one of the services that we developed and investigated. And the reason is that we, as I just suggested, we particularly value, there is a bit of technical complexity to it, because our participant profile is quite limited. We want to protect the participants' information. But we, as you can see there from the time series, there is some information we could rely on. So we're going to start with a couple of these services. We have to build an ML platform, just like a PlayStation. The process is very similar. Build this platform, and the platform is relatively similar to the one I showed you earlier. However, there are differences, and this one's on Google Cloud. Note that that's a dramatic difference, but different enough that we can use different technologies. So BigQuery is our platform for storing the data, Looker for analytics, Kafka for data for streaming. And I don't know that I included it here, but yeah. And over for the ML platform, we use a tool called Vertex AI from Google Cloud, which is a nice advancement. When we were PlayStation, these cloud offerings were much more limited with AI/ML. Now they're much more sophisticated. Amazon has theirs, Google has theirs. There's Vertex AI that's in this layer here. I won't talk too much about now this technology. What I thought I'd transition to is the similarities, the commonalities of how to architect the team, the individual. So you might encounter this in the future as you go into industry, or even maybe even nonprofits if they're doing this. Let's say you want developers to help you build your service, ML engineers of the sort who have a team manager, and then there's a product manager, the person who helps to summarize the requirements of the service and make sure that there's alignment with the opportunity, possibly an owner of this product, the individual who is most closely connected to the work that's going to be detailed. Maybe that's going to be a technical lead and a scrum master. And since we're in both cases, we are agile. The focus on this is on the individual developer. So we want to deliver those technologies. Often these presentations are about the algorithmic discoveries, mechanics of it. Is it random forest or neural networks or logistic regression or again, that's often the way the presentations go. This is different. This is about how to put a team that puts it live. And these are these platforms that originally had kind of stacked on top of each other. The data ocean part would be the layer for data management. And most of the work, of course, an ML engineer would happen in this middle layer of processing data and applying machine learning. At the far right, then you do some online evaluation, ideally A/B testing. There are two tracks that, I have more versions of this presentation that are narrower, but I thought for this, as a more high-level characterization, there's a challenge of developing and automating the solution and then operationalizing it. The idea of monitoring and alerting, which maybe for the scientists may be a little less natural for them as to how to continually monitor and alert on the problem, as opposed to a software reliability engineer would be needed here. But ideally, the team can do it all. And these are another way that we found helpful to characterize the different skill sets that are required from your ML engineers, where mostly you think of model training as being this important skill, and certainly that is an area where you need training in, but it isn't the only one. The idea of deploying it and applying inference to the right of that, and then doing A/B testing, online evaluation, maybe before, after. But also the data processing to the left of that is also a critical skill that we need to look for when we hire, let's say, an ML engineer, or maybe, of course, a data engineer. Now, focus on this one. So examples of developing, so code reviews, unit testing, load testing, these are more software engineering skills that nowadays is being expected from an ML engineer working with IDEs, Git, Jenkins, Kubeflow. To operationalize, as I mentioned, what the task is, but here's an example of the latency. Is if it's over 200 milliseconds, then we need an alert, because sometimes there's hiccups in your nodes underneath the cover, but sometimes then it gets worse, and we often, not be aware of this problem, but at PlayStation, we needed it because we would have a global scale. And so sure enough, some Saturdays I would get a notice that something was up and down, and I would have to intervene. And we'll skim through these different skill sets that we've noticed are kind of important to elicit from individuals we hire. The idea that you can work on SQL is fairly important. The idea that you can work with tools on data preparation like Spark or data warehouse, or parsing JSON data. Parquet is a file structure that you then might need to become an expert in. Then when you go into batch, you have a feature store. Again, it's returning to things like Spark and Python. This is just a slightly more granular version of what just happened earlier, except maybe not in cleaning up data, but in organizing it with creating a feature for how a person behaved every 24 hours. More sophisticatedly is to then do stream data so that you can have updates to that information within, let's say, 5 minutes or possibly seconds. This one's pretty straightforward. Most of you are familiar here, but it might need TensorFlow and Spark ML as the tools that you need to get really good at, instead of maybe Jupyter notebooks on Anaconda that doesn't typically convert to an environment where we can productionalize it. Then we deploy it. So now that we trained it, we want to regularly apply this model every day, or maybe real time. Let's say it's every day, where you want to predict whether a customer is going to drop off or not. That can be done offline every day batch. For real time, this is when the much more expensive, complicated route where we need to perform a real-time query, just like for the PlayStation's recommendation system. And so here you need to then translate to more real-time statically typed languages like Scala, and with Kubernetes, NoSQL databases, gRPC, Protobuf, much more advanced. And then not everyone gets training on how to perform sound online evaluation before after hypothesis testing. So the technical skills are maybe more academic, but some SQL will be needed. So that's the gamut of the team that you just saw above. You need to ensure that all of these skills are covered. Otherwise, you'll be blocked, because unless you can do it all, you can't turn the service on. To do that, then, this is at SIE, and we led myself and several of my reports had a university where we graduated members to ensure that they did have the skills required to deliver, to participate in an ML engineering team, and many of these did. So I flew by with this information, Lori. I think that covers me, though. I can, of course, return to any of it if there's some questions. I think that would be best to leave it to questions and answer now.
Yes, thank you so much, Gabor. That was super interesting. I particularly enjoyed your comments about the technical skills that will be required by, or that are required by industry to be part of an effective ML team. So yeah, thank you so much for your insights. With that, I'd like to proceed directly to the Q&A session. So if you do have a question, please raise your hand. Imad, would you like to kick off the Q&A?
Yeah, please. Thanks, Gabor, for a very interesting talk. So my question, I have two questions. One is, I mean, what's interesting about a lot of the systems that you're mentioning here is they're sort of user facing, and they're also using user data. So my question is on the privacy aspect of it. So how did you manage that, especially that it seems you were using real users, you weren't trying to emulate or fake user activities, or you were trying to make recommendations that were to real users? That's the first question. The second question I have is more about drift in these models. So I noted in some of your slides, you mentioned, this would happen offline, this would happen offline. And so, for example, I think the features that you engineer, or the feature engineering piece, was mostly offline. So how did you manage and monitor drift over time, particularly just to make sure that the models were still relevant, or the features were still relevant?
Sure. Well, So 2 questions. The first one's on how to respond to privacy and ensure that the user's data is protected. It's a critical question for us. And the way and now maybe the industry breaks through with this, is to tokenize the ID. So even certainly the IP of the user has to be sequestered. Even the ID of the account is something my team and I did not want to see. So we required an anonymization, a separation where there's a table that can differentiate the private information, an identifier to an anonymized identifier. So there's a section in our data warehouse that only relates to this ID of a user, where on one side is all the personal identifying information, PII, from the information that is does not identify the individual. So now we get this ID, and only we can find out what when I showed you that series of the activities that one of our participants performed, how many tasks, I could not tell you who that was, nor anyone in my team, but we can say how many tasks they did. Also, we can't tell you maybe whether they answered that they had a headache or not, but I could tell you that they submitted the form of the headache feeling form and how long maybe it took them to fill it out. So sequestering the PII data is now fairly typical, and we did that at both companies. Though there's products coming along, we had to do this with custom work. My read is that in the future, though, there's tooling technologies in the clouds that allow for this separability. Now, your second question was on drift, and so let's start with an easier one, which is model drift. Say, and there, what we did is assess how the performance of a model improved when we refreshed it. So let's say we have a model, the trained model, and I challenged my ML engineers to do this at some point. Turn off the service so it only updates every week, every 2 weeks, every 3 weeks. And as we put in the refresher, we can do an A/B test of the older model versus the fresh model to see what the lift is. And now we can play back all of this over months, even a year, to see what the net benefit is of doing this process of refreshing ever more frequently. And for many models, it turned out to be actually quite stable. The model training itself to be only, let's say, on a weekly basis that we would need to retrain. Now, let's say features. Now, this is the features of that are being predicted on. There, we had much more fresher data. So every day, we would update some information about, let's say, what the customer did in the past few days. Now, it could be even fresher, of course, and that's where we do have key value stores that allow us to reflect the freshest data. So one of the, say, features would be their most recent purchase. We don't want to recommend something that they just purchased because we don't want to wait for an entire day. So there are some attributes which are very expensive attributes, but possibly helpful enough. We would commit through that Kafka pipeline to then update our key value store that reflects what items they've most recently bought.
So maybe just a quick follow-up. Thank you so much. Yeah, just a quick follow-up. So in the case of model drift, so if the model did drift too much, what did you do?
Well, we just said, well, we didn't encounter a situation where it drifted.
Okay.
Whereas we went from month to week to day, we go, wow, if we could do this like every hour, the net benefit would be millions of dollars, and it would warrant going into a real-time model.
Okay. Okay. Thank you.
So maybe should I go? Thank you, Gabor, for a very fascinating talk. I think what fascinates me in your talks is that you're working on two very different domains. One in which the system that may recommend like the wrong game, they just require users to maybe click on different places to get the games they want to play, while the other is like may have more severe consequences if the recommendation of the model doesn't work well. So what I'm interested in, if you can elaborate, like how does this like very different domains, both domain of action and regulatory, impact the team and the choice of the technologies? So I can imagine that at Sony, you're less constrained to pick new technologies and new models and things that haven't proved to be working and just try it out. While on the Medable, I think you might be a bit more conservative. So I'd love to hear your thoughts on that.
Yes. Yeah, it's a discovery for me, and I've been here now long enough to help share that with you. That there's a distinction between, let's say, when we were predicting dropout, I was in the scenario that I was suggested earlier. What can we do with that? So now we know we could, but do we just throw it into the mix? And no, we need to ensure that the science doesn't affect the science. So, for example, the plan is to inform the site leader about the information. So usually they would do this by looking themselves at data. Now we would just give an earlier signal. It's still up to them to follow through on that information. So we're not changing the basic process, the basic understanding of the decisioning and the expertise around it in that scenario. But yes, we have to ensure that anytime we apply a model that we do not break the science of it. And of course, that is has several aspects to it. One is to ensure that it doesn't ruin the ability for the study to then determine whether it's safe or efficacious. But also that you don't want to introduce new adverse effects to the patient. The patient's safety is number one. So we work through a lot of our domain experts to ensure that the information, the transformation aligns with both the safety and the science of it. I could probably have other examples, but I think I'll stop there for you.
Yeah, thank you so much.
Thank you, Diego. Jasmine, please go ahead with your question.
Hi, thank you very much for this presentation. My question is a bit of a follow-up from Diego's question. So I was interested in knowing, because you presented us with two very different use cases. So one video games and one that's more, healthcare related. So I was wondering how important it is for engineers to have the domain knowledge, right? So you emphasize on the technical skills, but how important is it for them to have this domain knowledge? You mentioned that they collaborate with mainly domain expert, but do you ensure that do you have to ensure that your engineers also have this domain knowledge, and if so, how?
Yes, one thing I've discovered in this domain are SOPs, standard operating procedures, which is a fairly itemized characterization of the work that we do, so that whenever we onboard somebody, they can now benefit from the documented flow of activities that we expect everyone to perform. When you see the possibility of a data breach, here's all that you go through. So apologies. So that's more about ensuring that when we bring somebody on board, that they're trained in this new domain. And I've noticed that in the healthcare, there's much more sophistication there to ensure that everybody understands the process and the limits. Now that's procedural. There's still domain information, and there it involves certainly lots of presentations. So at Medable, we have regular monthly or more presentations to understand aspects of IRBs, these regulatory bodies, how do they work, is a presentation that happens for the entire company that's recorded. We're a global company, so it's often recorded, and then there's plenty of channels where they can start to ask these probing questions. What are ECOAS, clinical outcome assessments? What flavors are they? PROs, patient-reported outcomes? What are endpoints in the study? All that is discussed quite regularly I don't, there, it's not that we formally have a course that they need to go through, say, for how to use your product.
Okay, thank you very much.
Thank you, Jasmine. Does anyone else have any questions or comments or anything they'd like to add? We have 5 minutes, maybe a little bit more.
Lori, I had a few questions, but I wanted to give the chance to others to ask, so maybe I'll jump in. Okay. So Gabor, I wanted to hear from you about the teams that you put together
Sure.
to tackle these challenges. And I know you talked a little bit about what developers do, but I'm curious, who else, what are the teams composed of? And the reason I asked that question is because I think typically, at least in university, you always think that it's just technical people around the table to solve these problems. But I feel like in industry, it's more than that. And so I want to hear your perspective on that, perhaps to
Sure.
give insights to us here in the academic institutions.
Fine. Yeah. Yes, I could have, and maybe one day I will expand on that illustration of the team itself and their interaction with the greater organization. I did mention the product manager. So the product manager often, well, many do come from a technical background, but not necessarily. So that's one individual that ML engineer and or software engineer would interact with frequently. There are also designers, especially for the more front-end experience it becomes, then the more of a designer would weigh into how to assess the value, give direction for the hypothesis generation. So designers. We also have UX, user experience researchers that now actually say interview users to understand the experience and qualify it, characterize it, either qualitatively or quantitatively. Next, beyond that, we have possibly the delivery team, so the people who actually use the product. Often, we have representatives within the company that either, of course, handle the support, but in a much more, let's say, proactive manner. These are individuals that are often part of our work. Sometimes it's because there's a bug, and so now all hands on deck, and who's in that meeting, but a few engineers, a few developers, plus a gamut of other individuals that here at Medable, for example, could involve the compliance team would be in the fold to ensure that we have the clear understanding of where the compliance is broken. Sure, I could add others that I think starts to touch on the breadth of communication that happens now.
Thank you. Thanks, Gabor.
Okay.
Lori, if there's just a minute for a quick, very brief one.
Yes, go ahead, Diego.
Yes, I was just curious. I saw the same in the presentation. I haven't heard it before, like this intelligent user interface. So what would that be? Is just the fast state of an intelligent system, or there is also intelligence in the composition of this interface?
Yes, well, one example, though, I'm Canadian, I don't know that I did use this tool, but here in the US, they have TurboTax as a solution that helps you put your taxes together. And there you can see the navigation where it says, these are the questions you need to answer. Hey, this doesn't reconcile. So there's a level of guidance that happens inside. It could be a recommender systems where now that's the PlayStation experience where, hey, we recommend this. Oh, now that you've done this, there could be follow-on consequences. Well, if you bought this game, you may want to get these add-ons, or because you played this. So there's some logic that see consequences for each choice. That if that's a very complicated sequence, and more intelligence can be embedded there with possibly a knowledge graph that supports it.
Right. As a PlayStation user, I have dealt with that for many years already, so I know what you mean. Thank you.
All right. Well, we're nearing the end of our session, everybody, which is kind of a shame because I feel like we could just continue on with all of these interesting discussions. But if there are no other pressing questions, I would like to take this opportunity to say a huge thank you to Gabor. I'm so glad that we had the opportunity to benefit from your knowledge today, and I always find these talks very interesting. It's a great opportunity to learn from your professional experience. So thank you so much, Gabor.
Yeah, my pleasure. Reach out to me either by email or LinkedIn. Yeah, happy to help you in your careers.
That would be wonderful. Thank you. And we hope we can invite you to other events that we plan for our program. So thank you very much, everybody, for joining. And with that, I will wish you all a happy Friday and a great weekend.
Thank you, Gabor.
Yeah,
Thanks.
thank you. Sorry. Bye-bye.
Bye-bye.
Thanks, everybody. Bye-bye.
Thanks, Lori.
Thanks, Imad. Yeah, some good questions.